This video is on ions. Ions are atoms with the same numbers of protons, but different numbers of electrons. Not all atoms form ions, but ions are fairly common amongst atoms and elements. Depends on where you are on the periodic table, and that sometimes helps you understand what ions are going to be forming and what ions are not. But let's do some examples. First off, sometimes when you become an ion, you become what's known as a positive ion. An example of elements that become positive ions are the alkali and alkaline earth metals, so group 1 and group 2 of the periodic table. A lot of transition metals also form positive ions as well. So let's take an example of lithium. Lithium on the periodic table has a 3 for the atomic number, Li for the symbol, and then a 7 for the rounded atomic mass. That means we have 3 protons. We have 7 minus 3 for 4 neutrons. And then finally we have 3 electrons. So if we were to draw lithium, we have plus equals 3, 0 equals 4, 2 in the first shell, and then 1 in the second shell. Well, what happens is that atoms really like complete outer shells. It's why they form compounds, or it's one way that they form compounds. And because lithium has this outer electron, it really doesn't want it because it makes that shell kind of unstable. It's why lithium and all of the alkali metals are so very reactive. So what ends up happening is this atom will eventually get rid of that. And so when it gets rid of that, what ends up happening is it gets rid of that outer electron. And so then what it looks like is it's got that 3 protons, that 4 neutrons, and then only a complete outer shell. But if we take a look at this, there are supposed to be 3 protons, which there has to be lithium, but now there's only 2 electrons, which means there's one more positive than negative charge, which means that this becomes Li plus 1, and is also known as a positive ion. Another negative ion. The halogens are a very common family group that makes negative ions. For example, if we've got the element fluorine, fluorine on the periodic table is number 9 and has 19 as an atomic or rounded atomic weight. So our protons are 9, our neutrons are 19 minus 9, giving us 10. Our electrons are then 9. We will have 9 protons in the center. We will have 10 neutrons in the center, or the nucleus. 2 electrons in the first shell. 1, 2, 3, 4, 5, 6, 7 in the second shell. Now, as we've talked about before, there should be, or there's not should be, but 8 electrons would complete an outer shell. 8 is sometimes like the magic number for atoms. And what happens is this fluorine atom really wants another electron. It wants it so that it has a complete outer shell. That's what will make it feel more stable or make it better. Well, what happens is it actually gains an electron. So now fluorine doesn't have 9 electrons, it has 10. So that's how we get this different number of electrons thing up here. Well, because there's another electron now here, and now we have a complete outer shell, if we were to count and compare the number of electrons to the number of protons, we have 10 electrons and 9 protons. So what this ends up being is a negative ion, or an F minus 1, or fluorine negative 1. indicating that it is in fact a negative ion. That is the basics of ions.